Welcome to my terrified face. It's happened. Okay, I will tell you what's happened in a moment. First, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, okay. Hello to everybody. Oh no, not again. Okay, so this is going to be embarrassing. I can't remember the URL for the new URL for TTS. So Pete, your oh no, not again Hitchhiker's reference did not come through. Where is your towel, Pete? You'd better know where it is. There's where? Hang on, I'm gonna try to find it. It was called something like Stream Buddy. Okay, so the backstory is Mitchell. I'm just gonna go to the Better Portal thing and see if that works. Maybe it aliases it or something. Okay, so no, there's something running there. It does not look complete or functional. I can't log in. No. Okay, so there is a new location. What Mitchell did was when he was creating the TTS for the stream, he set it up on a, I think it was like a temporary or a generic sort of, sorry, I just had a camera powering down. Yeah, a hosting thing, like an app hosting thing. So the URL that I've been using all of this time just recently changed because he set it up as like a product essentially. And Pete, no, I won't talk to you about life. But I will say it has been a pleasure opening for you. Please walk through me again. So it just changed to a new URL, and it's something like streambuddy.something, and yes, Crispian, a nice dose of DA. Stream buddy, no. Stream, no. No, okay. Maybe, I just don't remember it. Please do not press this button again. Jordan. Okay, so I'm kind of dithering at the moment because I'm half wanting to get the TTS working and I just can't remember it. All right, I think the way that I'm going to resolve this issue is I'm going to open Discord, but first, because it makes me uncomfortable to have you up so close and personal, I'm going to push you to a bit of a distance. Okay, you can at least have something interesting to look at while I'm messing around. So what I'm going to do is try to find, Mitchell would have sent me the URL at some point. Where is it? Ah, here we go. Here we go. Cast note. Oh, it's got an internal server error. No. Oh, hang on. Loading. No. Internal server error. OXRS visit. Yeah. So during the stream last week, Mitchell had a hard disk die, and he ended up doing some recovery on it immediately after the stream and got the service back up and running, or got the computer back up and running. But it could well be that it's just, yeah, he's having to do some infrastructure work to get it all sorted out. Okay, let's throw this up here. What I need to do is have a layout from the live stream thing with the windows set up so that it always shows the chat up on the screen. I'm going to move this across to about here somewhere. Yeah, about there will do. Because the thing is that people can't necessarily see the chat when they are Um, yeah, when they are watching this later, which most people do. Far more people watch these streams non-live than live. So, good morning to Stephen W., Henrik, and Imi. Gateway Community Church Live is Imi. Oh no, sorry, not Imi. Amanda. I said the wrong thing. Hello, Amanda. Crispian, Stephen W., Sharky, Matt W., David C., Stephen W., Lionel is here. Hello, Lionel. Scrolling down again. Tabriz. I think I said hello to... Yes, Tabriz. Welcome. Estonia is in the house. Some call it fun. Stephen George, half Greek geek. Which reminds me, Nerd Brags. There is a Nerd Brag coming up. Russell Rennie, Paul Schulz, Pete. Got any mules? Hang on. No. No. Oh, stop that. Stop that. Simon, Andrew Ruthven, John Whips, Scott Miller, Andrew Brown, Jordan. If I missed anybody, I think I got everybody that was in the chat. I've just been scrolling down looking at their names. I haven't actually been reading messages much. Yeah, Pete, it gives me a headache just trying to think down to your level. Oh, there is a pain in the diodes down my left side. So depressing, Pete. So depressing. Okay, so everybody. Henrik said, how's the TTS leaves? No, it is not TTSing at the moment. It is coming up with an internal server error when I try to load the page. So the TTS is... I'm not getting you down at all, am I? Yeah, Crispian says, Amy loves that diode quote. Yeah, during the week, I've had... It's kind of weird. I've had a whole lot of pain down my left leg, and it's from the hip all the way to my feet. It's like there's a little bit of pain concentrated in around the joints, so the hip, the left hip and the left knee, but it hasn't really been localized to that. It's been the entire left leg has just hurt, and you know, with no explanation for it. Yeah, so it has really felt like there is a pain in all the diodes down my left side. Pete, would you like me to go and stick my head in a bucket of water? Crispian says, pinch nerve. Maybe. Yeah, that could be it. Sparring match last weekend and actually it's a fight injury, says David. Yes, maybe. Last weekend, last Saturday striking, I was a mess. So turns out, I've been feeling absolutely smashed for quite a while now, and I've been putting off doing anything about it. Ended up going to see so last Saturday at Muay Thai, I was just exhausted. It was like I had no lung capacity at all. And I've had this cough for a long time now. And so after that experience, I finally relented after several people had been telling me over and over again for weeks, go and see a doctor, go and see a doctor. So I eventually did. And the doctor said, get thee to the radiology department. So I did, and had chest x-rays, and turns out there is a reason that I've been getting out of breath. Yeah, so something I had not heard of before, like a weird thing, walking pneumonia. So the bottom part of my right lung. Yeah, so anyway, I'm on medication, on antibiotics and stuff. So yeah, no wonder my lung capacity has been decreased, and I've been getting gassed really quickly. Like get tired just walking to the car. But, and also, yeah, as you would have seen on previous streams, I've had a persistent cough for a long time. It's just like a dry cough that just never goes away. So, yeah. I get tired thinking of life, says Pete. Oh, Tabraze, I'm sure, I thought, okay, I'm sorry, Tabraze, you're in the UK. Who is it? There was someone who was a regular in the chat from Estonia. I must have been confusing your name with someone else's. Well then, Tabraze, the UK is in the house. Welcome, welcome. Yes, so what am I doing? Okay, what are we doing today, folks? Time to go to work's a kind of bad situation. No! You need to get more sleep, Henrik. Every single stream, you are thinking of Henrik. Oh, Tabraze, yes. Henrik. I am saying the wrong thing. Sorry, Tabraze, for thinking that you were in Estonia. Yes, Henrik. You are my Estonian friend. Yes. And it's not even as if your names are similar. They're not even close. Not even close. It's just some weird brain fart. I'm glad that's sorted. It's not sorted, Crispian. I'm glad that's sorted. So, nerd brag time. Nerd brag. Chuck them in the stream. Chuck them in the chat. Up there. Put them in. What cool things have you done recently? Just a little thing, a big thing, a little thing. So Alan, you're in the stream as well. Pete says you should get a map and put pins in it of viewers you know, not just the live stream are. Yeah, that's true. That would be really cool. Getting some kind of a world map. Which reminds me, one thing, I don't know if it's still there, it probably isn't, but many, many years ago when I went to Google in Mountain View, in the reception area, they had a big screen there with a globe, a representation of a globe which was slowly turning, and there was a visualization of queries, like Google queries, from locations around the world. So you would see like a tower, and the height of the tower would represent the number of queries that were coming in, like per minute or whatever the metric was from that location or from that region. And so you could stand there and watch the little things move over time as the different parts of the world went through their day-night cycle and activity change. So you could see, oh, there's lots of activity happening over in this part of the world at the moment. Look at all these queries that are coming in. So yeah, that was really cool. Has anybody in the chat been to the Google HQ and seen that visualization, and is it still there? How long ago am I talking about? Probably, when would it have been? Probably 15 years ago that I saw it there. So I don't know. I don't know if that sort of visualization is still there. Henrik said, seems you really need some of the liqueur candies to wake up your memory. Yeah. Chocolate. Oh, okay, so nerd brags. Alan Madsen converted an iMac 2011 to a PC screen. That's interesting. I have a couple of old iMacs, like 27-inch iMacs, where I've got one upstairs here on the mezzanine, which died a while ago, and converting that into a screen would be interesting, but I just don't know if I could be bothered. I'd be interested to know how you did it though. What is the internal connection between the iMac main controller board and the screen? It's not like just an internal HDMI cable or anything like that. It's much more optimized than that. But maybe the signal is just HDMI. I don't know. I'm curious to know. Debraze says, this is what happens, Henrik. You miss one stream and you're forgotten. Yeah, I have the goldfish memory. Okay, Grant says, I welded badly our ride-on mower deck back together. That's a pretty good achievement. I like doing physical things. I need to do some welding. I've got pieces of steel cut out in the factory, ready to build 2 more benches. And I need to order steel to make another 2 beyond that to go in here to set up Tom's workbenches. So I need to do some welding. Pete says, I finally got my OneDev locally hosted Git repository talking to a CI builder. Next step is to get a OneDev command line tool providing the MCP to talk to OneDev. Woohoo. Those are words. Yeah, so a CI builder is a continuous integration builder. Get a OneDev command line tool. Okay, so you're doing a whole lot of wiring of infrastructure. That is handy. It's always nice to put some things in place to streamline development. That is pretty cool. Yeah. Anymuel says, got sick of Home Assistant in a Docker container, installed full OS on bare metal, now getting more things onboarded and playing with OpenASP and ESP Home 2. Good one, Anymuels. That is cool. And also, where is the famous mechanic? I wonder, did he or she not get paid? The famous, TTS mechanic. Yeah, I have paid nothing. Mitchell has been doing all of this out of the goodness of his heart. So I'm just grateful for any time that it works. I don't want to put pressure on or have any expectations or anything like that. It's not like I'm paying for a service where I want to get 5 nines of uptime or anything. So yeah, that's cool. Live streaming 20 boxing fights, a little bit tired as I started work Friday at 2 p.m. on Friday. Amanda, take it easy. Live streaming 20 boxing fights, okay. That would be hard to follow all at the same time. Andrew says, for cool website analytics display, check out Logstalgia. A colleague wrote it. Doesn't use a map though. Maybe I should suggest it. Logstalgia. What is Logstalgia? Logstalgia. Now, many years ago, there was a waterfall visualization. Oh, no. Logstalgia, which I had running up on a screen at IVT, and it was, so there were a couple of visualizations. One was like the server in the middle, and then other circles around it, and connections going in and out. So it was like a wheel and like a hub and spoke sort of thing, and the size of the outer things would vary depending on the number of connections or the data throughput. And there was another one that was like a waterfall sort of thing, which was really cool. So I'm gonna, mute this so that I don't get, that's cool. So that's data flowing left and right. So data going between, what is that? That looks like IP addresses on the left, going to wherever it is. Oh, look at that. Oh, is that sped up? I don't know. I can't tell. Maybe it's not sped up. It's just that counter is going up very, very quickly. Okay, I'm going to check that out. Having cool visualizations of stuff is fun. Oh, Crispian says, I became a bit more of an AV geek by joining 3 by streaming plane spotter groups this week. Oh, okay. Amanda says, converting the screen sounds like a barbecue activity. It could be. Actually, one thing that I had thought of, I've thought for quite a while, is that it would be fun to do actual hands-on activities at the barbecues. But it turns, I don't know how practical it would be. People often bring along things and often end up doing like soldering repairs or looking at projects that people have brought. But that's more like a little show and tell sort of thing. And I thought what would be cool would be to have an actual project where for a couple of hours everybody is at the workbench working on something. Not necessarily the workbench here, probably a bench out in the workshop, like in the loading dock area, so that it's more like a table you can gather around. And I don't know, but doing something like a group activity like that is quite hard. It's very hard to organize, and there will always be people who aren't interested, so yeah, it could be a tough one. And also I usually end up running around talking to different people constantly and don't get more than a few minutes with any one particular person. So it could be tough. Where are we? Stephen says you could offer Mitchell a whole $1 to guarantee 5 nines of uptime. Yeah. Is that like when you give $1 to a lawyer so that they become your lawyer because you've paid them, so therefore they can't give up your secrets? Mitchell, I was born into the pain, I am used to it. Stephen says, well, now I'm finally deploying to prod server, should be solid. Yeah, cool. And Mitchell has a question. Anyone used Coolify with internal service running HTTPS? HTTP all fine, but HTTPS being a Peter. Yeah, needs to scroll down the chat to see me tell him. You're right, Pete. Okay, I've been spending the day pricing up an entry-level Threadripper Pro workstation, but app stopped when the price hit £8,000. Oh, yeah. Speed soldering, solder a component, tap out to the next person. Teams, which team wins? Which team wins with a working device? Jordan, I'm in the price to performance game, so the machines are $2.5 grand each. And also, by the way, hey Mitchell, welcome to the chat. So, what am I doing? Okay, my terrifying nerd brag is that I submitted a talk to Everything Open to this, which is in Canberra in January, for regarding Testomatic. So I submitted a Testomatic talk, and I just heard a couple of days ago that it's been accepted, which is scary because now I need to finish the thing that the talk is about. But as Crispian pointed out when I said, oh, I've got to finish it, the talk doesn't necessarily need to be about the finished device, it can be about the journey. It can be about how we got there, or how we are getting there. And of course, it's never, like all projects, it's never going to be finished. But I do want to have it at the point where it is a useful thing and, yeah, an actual thing that's in daily use. Using a wildcard cert. Okay. Half Greek Geek said, I made a rotary RFID coin dispenser. What? Okay. Are you talking about coins with RFID in them? Are the coins rotary? Is the dispenser a rotary mechanism? I need more details. I need more information. It sounds too interesting to not know what you're talking about. Yeah, so if you are in Australia and you can make it to Canberra, then please come along to Everything Open. It's a pretty cool conference. This is the continuation of what used to be linux.conf.au, which started with, so 1999 was CalU, the Confederation of Australian Linux Users, which Rusty Russell convened here in Melbourne. And then 2001, that became linux.conf.au in Sydney. And then 2002, LinuxConf.au in Brisbane. And that was the first time I attended. And so LinuxConf continued in that form until a couple of years ago, when it converted to Everything Open, because the scope of the conference is broader than just Linux. It encompasses things like open data and open hardware, open source software more generally than just Linux. So, and there are other things going on. I'm not going to go into that too much. There were whole issues around not being able to run the conference in its traditional form during COVID, and lack of volunteers to run it. So all of those different pressures ended up resulting in the rebranding, which I think originally was intended to be just a temporary rebranding, because it was going to be an LCA that you have when you don't have an LCA. And now it has become the thing. So now it is Everything Open. Okay, so Half Great Geek. So the 3D printed coin with RFID chip and coil inside, then loaded into a stepper motor driven rotary dispenser. Okay, so you can dispense RFID tags in tokens. Yeah, cool. I'm curious to know what the application is. You have to spin the RFID chip to get a coin? Okay. I don't know what that's about. So we're already nearly half an hour into this, and I've been doing nothing. Okay, so I will give you a quick update on this, because where we left Testomatic last week was I was trying to flash firmware onto a target device, and I couldn't get it to work. And can you see it from here? Okay. And I discovered the problem. The problem was a solder joint on the board. In fact, I'm going to get it. How am I going to do this? I'll switch to the overhead camera temporarily. So this is the Testomatic as it is now. So what I've done since the last stream is we now have the gantry over the top that you can see. I'll talk about that a bit more in a moment. There is this clamp mechanism. So this is a woodworking clamp, but it's what typically gets used for these sorts of things. There is a pressure plate, and there are these pins that push down on the top of the device under test and clamp it. So I'll see if I can do this in a way that you can see. I'm going to tip the whole thing on its side, which is very precarious. I'm going to have to hold it together and creep it down towards the edge of the bench here. It is so hard to see something that's transparent. It's really kind of weird. Okay, so pressure plate, as you can see, is mounted to this clamp. And then there are these pins that go down to touch the surface of the PCB. So it's pushing on the PCB, it's not pushing on parts on the PCB. And the location of these pressure pins is selected so that it clears components. It finds open bits of the PCB. There are long ones. These ones are 30 millimeters long. They protrude down past all of the parts and push directly on the PCB. And then I've got short pressure pins here at the front. It looks to the left to you, but that's the front of the pressure plate. which come down onto the top of this big connector, because the device under test that I've got here, this is the water cannon motor controller, has this big connector on the front. So I'm applying pressure to the PCB and pressure to this connector so that it prevents any twisting, like distortion, as the pressure comes on. So if I now pull this lever down, you'll see the pressure plate descends. It makes contact with the top of the device, and then if I keep pushing, it's got like an over-center mechanism. It snaps into place. Oop, hang on. I've got to, because I'm holding this sideways, this is not very, it's quite precarious. And okay, so I'll push it down, there it snaps into place. And now, as you can see, it is all held there. The pressure plate is pushing down on the motor controller and it is pushed onto the pogo pins. So, and if you look, yeah, if you're looking straight down, this is the point of view looking straight down as it would normally be used. This is directly in front of me now. So normally what you would do is you would release the pressure plate, put the device in under test onto the thing, pull down the lever, the pressure plate locks in place, and now that is all secure. So now, I'm just wondering if I can give you a better view. Okay, I'm going to try giving a better view with the front camera. And this is not plugged in right now, but there you can see the gantry at the top has the clamp, which is pushing down on the pressure plate, which is pushing down on the PCB and holding it on the test area. So I will grab myself a power cable. This is coming from one of the lab power supplies, which is currently turned off. Give me some juice. Okay, so it's now booting up. You can see the power LEDs have come on the right hand side and the Pi is booting. So now where the problem was, on this particular test module, and now that I've powered it up I can't take it out to show you, underneath, under here, are the two little modules. You can see where the blue LED is there just near my finger. That is the ESP flasher module. So that is USB in on one side, and it is the serial output with the RTS and RTS CTS control to reset and IO 0 on the target. And there's the CAN bus module just in there. You can't really see it very easily. Okay, so the reason that I couldn't flash last week was when I disassembled this and I inspected this module carefully under the microscope, I discovered that one of the transistor legs on the reset circuit was not connected properly. Okay, now it's up and booted. We can see that we've got 3.3 volts and 5 volts on the power rails for the tester, but the device under test is turned off. So I'll press V in on the touchscreen and you can see it's just turned on the V in, and we now have the device under test powered up. So now I can SSH into this because at the moment I don't have, well, we've got, like from here I can select client and then the device is MCM. That's what this actually is. I don't have it reading the EEPROM yet. I could put the serial in there, I could click run test, but this is not actually running the modified firmware. So what I'm going to do is I'll leave this sitting just here. We'll switch back to here and no, remind me later. Okay, so what am I doing? Zooming in. Let's try this one. Okay, so we are on the Test-O-Matic and okay, what's been happening in the chat? Set up a certbot, Cloudflare. Okay, so people talking about SSL Don't use a CF, move from them. Same page, let's coolify, caddy set up. Okay. There's a whole lot of discussion about how HTTPS is being set up. Huff Greek says, I sent you a link to demo. Oh, is that further back up in the chat? Where is this? Where is this? Proxy certs, a whole lot of stuff. Got a bench light. Yeah, let's encrypt LE. How far back do I have to go? I sent you a link to demo, says Half Greek. I couldn't see the link. Unless you sent it some other way. Is it in Discord or somewhere like that? Pete, you're welcome to fall apart where you're standing. You don't need to go and stand in the corner next to Marvin. Besides, I think Marvin's in the corner, so he'd get in the way. Okay, what are we doing? That's right. So CD test runner, and if we go into targets MCM, this is where we were at last time. Remember, there's this upload script, which is the one that I was messing around with, and it was failing, and I couldn't figure out why this was all failing, and it turned out it was the hardware problem. So there was nothing wrong with the design. In fact, I'm just gonna run this now, and what should happen is it should flash the firmware to the device, and then we should hear the device, so the motor controller, do a double beep after it's finished. So let's just see if this is probably going to fail, just to make you all laugh at me. Okay, no, it's doing something. So it is writing the binary to the water cannon motor controller, and in a moment we should hear a beep. There we go. Yeah. So, and if we switch to this camera, see the flashing LED that is on the motor controller? That is booted, and the flashing means that it is trying to initialize CAN bus, or it has initialized CAN bus rather, but it has not seen any other devices on the bus that it's talking to, which is why it's flashing yellow. So if it was, so that is CAN initialized, trying to talk to something. Once it was actually talking to something over the bus, it would start flashing green. But there's nothing there for it to talk to, so that's why it's like that. But the point is, this is now working. In fact, I want to try. Upload, manual check. I'm going to try, I'm going to turn off a couple of things. Enable printer, I'm going to set that to false, false, true. Okay, let's see if this works. I don't actually even know if it's going to work. Oh, I'm going to need to I need a keyboard. How am I going to do this? I'm going to get the barcode scanner off the other Test-O-Matic and try that. That might be the quickest way, because I don't have a keyboard set up at the moment on that. I've just been doing everything through SSH. Now, which is the dongle for the... Oh, that's the Microsoft one for a keyboard. Oh, I could just steal the keyboard from this other Test-O-Matic, but no. Let's do it. Let's try doing it with the barcode scanner, which is going to make some annoying beeps, but at least it's a slightly more realistic process. Back to overhead. All right, so I've got the receiver dongle for the barcode scanner, and I should be able to just plug this into the USB hub on the back of the Test-O-Matic. And you can see there's a QR code. That is the QR code for this particular device under test. So let's see if I can scan it. Hey, it's scanned. Oh, but it's it scanned something. All right, I'm gonna have to get a keyboard so I can delete that now. Yeah, I don't know. Maybe I've got to do some tweaking on the code that parses the QR code, because it had a couple of leading characters on it. All right. I have a keyboard. This is my old keyboard, the one that I was using before I switched to the current Softplay Choc DIY keyboard. Right, plug in the keyboard dongle. Hang on, why is the screen failed now? What have I just done? What have I done? Oh, okay. The touchscreen is working, but the HDMI is not. I wonder if... I wonder why. What happens if I unplug the screen and plug it back in? It then said no signal. Oh, there we go. Now we can see it again. All right, so T-Rex, MCM, serial. I'm going to try... All right, I will delete everything that's in that. Okay, and then I'm going to try zapping that QR code again. Yeah, there's something, it's going to be very hard for you to see, but down on here, what it's putting into the box is not what the QR code should be representing. So there's some weird thing going on. Come on there. Oh, that's... And then there are sequential numbers? What? I don't know what's going on there. All right, I'm going to... If I switch to a different page and then come back to it, let's see what happens. Ah, good, okay. Serial is now empty. Or is it? No, it's not. All right, I've got to figure out what's going on with this UI. But that is not really the point for today. So, what am I going to do? Let's reboot this. I'm going to go to System, Shut Down, and then I'm not going to use the barcode scanner to try to put it back in. All right, so turned it off, turn it back on again. You can hear the fan start up. It's 10:43 and I've been talking about Test-O-Matic and stuff all this time. I was wanting to do something totally different this stream because the thing is, okay, here's the thing while this is booting up. Because my talk has been accepted for the conference, it means that I am going to be putting a lot of work into Test-O-Matic over the next couple of months, which means you are going to be subjected to a lot of stuff about Test-O-Matic over the next couple of months. And I wanted to do some, like, just intersperse it a bit. I wanted to do something a little bit different. Okay, it's booting. It's bringing up the Node-RED dashboard interface, which is what I'm using as a cheats way of doing this. So I'll turn power on to the device under test. I will pick T-Rex as the client. I will pick MCM. I will put in the serial. I am manual. Hang on. Oh, there is something messed up in the... I'm curious to know what number this goes up to. Yeah, there is something messed up in the... It's up to 500 and whatever. Why is there data in that field? I don't know. Anyway, I'm going to put in 3990 and then click Start Test. So in theory, what this should do is call out to that upload script. Let's just see what happens. Okay, start test. And is it flashing? Isn't it flashing? Oh, it's flashing. You can see the flickering lights. That is, and here we go. There it goes. It actually just uploaded. That's cool. Okay. So the where is it? Serial 3990. Yeah, it worked. That's weird. Okay, I gotta figure that out some other time. For now, the QR code scanner does not seem to be working nicely with this user interface. So I can now use this through the touchscreen to select the device type, put in its serial number, and flash the firmware to it using the script that is running on it. And we can now start actually doing testing directly using the I/O modules and the Pogo connections to the device under test. So, a couple of little things. Firstly, I need to do some refinement on this mechanism, on the clamping mechanism. Now, it's going to be very hard for you to see here, but what's happening is that because the force going down on the pressure plate is ahead of this beam, it's applying a torsional force. So there's a rotation force being applied to the beam, which is trying to twist it that way. And in fact, if I, use words. All right, I'm going to turn that off. I'm going to shut this down now. Shut down. Okay. So the Raspberry Pi should shut down now, and then I'm going to turn power off and move this out of the way because I want to move on to the other thing. But I'll just show you this. Raspberry Pi is off. Okay. There we go. No more power on this. So if I now, how can we see this? If I release pressure on this, yeah, I don't think you can really see it on camera. But what's happening is that this beam is twisting in the middle. It's because it's clamped on the ends against the uprights, the ends of it stay aligned vertically, but the middle portion is twisting slightly. So what I'm thinking of doing, yeah, you can't see it on camera. What I'm thinking of doing is turning this into like a C-beam. I've seen C-beams glitter off the shoulder of Orion. So what I'll probably do is move this forward to remove the need to have this 3D printed block, which will then also bring the vector of the force closer. So it's going to reduce the horizontal component of the force vector and keep the vertical component the same. So just moving it in closer to this bar is going to reduce the rotation. So that, if I bring this across, that will help. But I was thinking also of putting two horizontal bars, so top and bottom, and turn this into a C-beam, and that should totally stop any rotation of it and make it a bit more secure. But perhaps just moving it forward, that's actually a really good top-down view. You can see that the force being applied to the pressure plate is happening here. This is where that pin goes down from the clamp, and the beam it's mounted to is here. So there is this gap right there is the offset between the point of the force and the beam. So if the beam moves forward by the thickness of this 3D printed mounting block, that will reduce the offset and reduce the twist. Yeah, I reckon that's probably enough. Yeah, so what I should do is move these forward. But there is another issue here. Oh, I'm getting too much into this. Okay, I'm going to put this aside because there are all sorts of issues in terms of the way the pressure plate is mounted. accounting for different size boards, different size device under test, because the force ideally should be in the center of the board. And if I want to make an extended test module, which I'm going to have to do for some of my clients' boards, like I want to test boards that are significantly bigger than this, which means that the test module is going to protrude out the back of the tester, and the center of the board is going to be further back. So I need to be able to account for boards that have different positioning, different center points, and also boards where they might have a cluster of test pins towards one end of the board, which means more force needs to be applied there. So there are all these factors involved, all these mechanical issues to resolve. So anyway, that's where it currently is. So as you can see, it is now at the point where I can chuck a board in there, press flash, and it flashes it, which is really, really cool. So I'll put that away over there, out of the way. And okay, I'm briefly going to jump back to the chat because I want to see what people have been saying. Scott says, eliminate the 3D printed block. Yes, that's right, and move it. So what happened was I designed it not knowing what clamp mechanism would be there or how it would be attached to the frame. So what I did was I designed the gantry to be generic, just with 4 holes in it for mounting something, didn't know what, and then I so the gantry is just, oops, it is 2 pieces of 4.5mm acrylic sandwiched together to make it more rigid, and it has 4 holes in it. So I just set it up so that it would be a bit back from the center point of the device under test, but I didn't know what would go in here. So I then designed that 3D printed block that you can see, and that is what the clamp mounts on. So that's the adapter block. And that may need to change actually depending on the device under test to change the y-axis offset. And also I'm not really happy with those clamps because they don't have enough travel, which means when you release them, it doesn't lift the Peter, why are you dinging me? Which doesn't lift the pressure plate high enough to be able to easily take devices in and out. So ideally I want a different type of clamp, one which has a lot more travel in it, which means that this mounting mechanism may have to change again. So yeah, this is all still in the fine-tuning sort of stages. But what I could do, certainly, if I was set on this clamp in this location, what I could do is just get rid of these 4 holes, instead put in the 3 holes required for mounting the clamp, which are these 3 here, and move the gantry forward by the thickness of that plate, and then just put the clamp straight onto the gantry. Yeah, that would be the optimization if I was settled on and happy with that clamp as the final solution, but I'm not. I'm still working all of this out, and I may have to do different adapters or whatever, depending on what the clamping mechanism is. Whip clamp. Clamshell top, says Scott. Clamshell top. Train squirrels to hold it on. Yes, Crispian. Scott says, just set a brick on top instead of the clamp. Oh, how about turning it into a vacuum table, says Half Greek Geek. Stephen says, seems to need some alignment pins to stop the pressure plate from twisting. Yeah, that is another issue. That is a whole thing that I won't get into right now. Andrew says, would it be easier if the pressure plate was on a pivoting unit, rotate on one post and lock against one on the other side, putting cuffs on the post for it to push it vertically against? Okay, so there is an example right here. This is a mechanism out of, which is specifically designed for test jigs. And the idea is that you bolt this onto your chassis and then This point up here is a mounting point where you can attach your own PCB to hold the pogo pins that press down. So the idea is that you can either have pogo pins coming down from above, or you could put a pressure plate there with pogo pins from underneath. And the clamp mounts on here. So this is actually what I pulled that clamp from. Oh, excuse me. The clamp mounted on this, and then you can see it's got the two vertical guides. So even without the clamp in place, the pressure plate is constrained and it moves up and down on these two rods. So this is a really common arrangement for this sort of thing. And this is the sort of thing that I was thinking of possibly doing, so that the pressure plate is constrained. But the difficulty is, if we come back to here, the difficulty is making it so that the pressure plate is easily interchangeable, because the modules are interchangeable. I want it to be very easy to switch from testing one type of device to testing another. No, go away. And sliding out the test module and replacing the pressure plate are the two tasks. So the pressure plate itself needs to be on some kind of a quick release mechanism. Anyway, that's a whole engineering challenge. That's a thing for future me and or us to solve. Train squirrels, where are we? 4-post gantry, and then you can move whatever clamp you finalize on. Clamp across from the side, then no limit on height of equipment under test, says John. Pete says, you're all a load of useless bloody loonies. Yeah, I know that. I know that. Stephen W. says, overcomplicated solution. Compressed air pistons to press down and raise the pressure plate. Oh, Mitchell says, app is up. Nice, nice, nice. Okay, where are we? Cast note, was that it? Yes. Now that I've figured out what the URL is. Yes, yes, it's up. Okay, where do I log in? It says get started. Okay, connect your channel. Get started. Go to login. Here we go. Going in with my login. Oh, and now it's just taking me back to the get started. So it's looped me around. Live stream dashboard. Okay. Where do I log in? I'll go back to get started again. Oh, okay. Now it works. Then, okay, streaming now. Loading, loading. We're in, as all the good hackers say. Okay, let's do this as a quick test. Let's play this one. All right, I've got to turn the volume up. Try it again.
Woohoo.
Yeah.
Outside the box said, can you hear me?
I can hear you. Yeah, okay, we are back up and running. Thanks, Mitchell. Nice. Nice.
Pete said, life, load it or ignore it. You can like it.
Yeah. Oh, life. Okay, now, yes, and I've also been thinking about linear actuator to drive it down, so that you press a button on the Testomatic and it drives the pressure plate down, does the test, and then raises the pressure plate. Because having some, so Mitchell says, now we've got the 5 nines of reliability. So ultimately, it would be so cool.
Tabrez Malik said, TTS latency seems much lower.
Yeah, you're right. David, I think you have been denied on your attempt to use my voice assistant, which is actually muted right now. It's not even working. I haven't been using it for the last few weeks. So, not since the plugin broke. Anyway, that's a whole other squirrel to chase. Scott says, how about a big long travel hydraulic ram? Yeah, if we want to apply a heap of force. Now, pogo pin P75. I just want to do a quick thing So if we go to, this is something I'm going to need to, where are we? Force, million, 60, spring force at full, 100 grams. Okay, so yeah, 100 grams of force. I know grams isn't a measure of force. Should be talking about newtons. That seems like a lot. Okay, so the P75 series pins require, according to what I'm looking at right here, they require 100 grams for full deflection. So, hang on, I'm going to try to get to a thing. Okay, here we go. So here's an AliExpress page for pogo pins, and the number I'm looking for is force. Total package. Okay, 100 grams. Contact spring force for full deflection, 100 grams. So that means if you have 10 pogo pins, you need a kilo pushing down on your PCB. If you have 30, okay, I know this is basic, like primary school mathematics, but I'm just doing this to make the point. If you have 30 pogo pins on your tester, which is not a crazy number, like 30 is probably on the low side, you need 3 kilos pushing down on your PCB to fully depress those all those pins. So it is actually surprising how much you have to push down to fully engage them. Now you don't need to fully depress. It's enough to depress a little bit. So this is the contact spring force for full, like fully depressing the pogo pin. But still, we are talking about multiple kilos sitting on top of your PCB when it's in the test jig. Here it comes. Pete's comment. Ilix, welcome. Paul says, use a set of hydraulic rams at each corner equals constant force. Not necessarily, well, kinda, but then you can bend the board. There is a whole thing I could get into here about the design of the pressure plate, because the pressure plate needs to be applying pressure from the top of the PCB, counteracting the pins. And you can really seriously deform the PCB if you don't match it. And so what I've done with the current pressure plate design, hang on, why didn't Pete's comment get said? I don't know. Pete's comment didn't turn up in the TTS. Maybe, I don't know, yeah. A lot of industries use vacuum and it works well. Yeah, but you need a contact against the bottom of the thing to suck against. And the problem is that between the PCB and the test pin carrier board, there is a big gap with all of the pins sticking up. So you don't have an engagement
Scott
on the
Miller
board to
said,
pull it down.
TTS thinks Pete is too depressing.
Yeah, that's it. Anyway, that's why I've got it's back over there now. That's why I've got the pressure plate that covers the entire top of the PCB with the pins mounted at different locations around it. And one of the things you have to take care of is on your device under test, what is the distribution of test points? If you've got all of your test points clustered together in one corner of the board, then you need to apply all of the force at that corner of the board. And by having a pressure plate that sits flat across the top and then has pins at multiple locations, you can apply that pressure evenly, or you can adjust where it's applied. It's a kick ban, Pete. No. Yeah, and as Crispian says, the TTS is trained to ignore Pete. Yeah. Okay, now, what I actually wanted to show you today, get rid of that, get rid of that. In fact, I'm going to close this so that it reduces the temptation to keep talking about it. And what I want to show you today is this. This is, now some of you will remember from ages and ages ago, I had a rotary position encoder which came out of Plasma Steve's lathe. It's from the tool changing turret, which is a disc with a whole lot of holes in it, and there are BT40 tools that slide into the holes, and the disc can rotate to bring a certain bring whichever tool you've selected up for the lathe to load into itself. So it's part of the automatic tool changing mechanism for the CNC lathe. And we played around with the encoder at the time. I was totally confused, and then Austin found the data sheet. I'm pretty sure it was Austin. Found the data sheet from the manufacturer for the encoder, which made everything make a whole lot more sense. And imagine having the board fabbed in those colors, yeah, like a lime green. I think you can. Oh, let's try this. Layers. Where is? Oh yeah. If I go to layer stack, ooh, it's open on the other thing. Top signal. Where is it? Layer stack. Top. I thought it was in here that I could define it. Material properties. Edit material properties. Maybe it's not in here. Shapes, supply, masks, layer stack. Yeah, I thought the layer stack included the design rules and now located in the design rules editor. Okay, rules. Rule, check design rules. Layer stack, let's see if it's in here. Nope, still shows the same thing. Design preferences. Layer stack, still shows the same thing. Yeah, I think it depends on whether you've got a modern version of the layer stack, but on some of them it includes the parameters for the solder mask, and you can change it. So then when you generate the 3D render, it inherits the color of the solder mask that you have specified. But this is just the default fluorescent green solder mask that, in fact, if I change, at the moment I've got the camera set in perspective view. If I change it to orthographic, it all of those little flickeries go away. It doesn't have the rendering bugs of the bits of the copper showing through. You can see how, as I'm moving it now, the color is staying consistent. I'll move the cursor off it. The color stays quite consistent. There are no weird flickering artifacts. But if I change the camera to perspective and then I move it, oh, you can't see it on there. Hang on. Oh, you could just see it on there. Why has it stopped doing it? It was doing it just a second ago, right before I changed the camera. You saw all the flickering, right? Oh, okay. The rendering bug has gone away now that because I changed the camera mode. Weird. All right. So what I did was laid out this board as a way of being able to read that rotary encoder. I've got an ATmega 4809 on there running at 5 volts. These are inputs coming in from the rotary encoder. Let's make that a little bit more sensible. Drag that in. So what have we got here? Oops. Oh, come on. Where'd it go? Fit. All right, so we've got the usual, nothing surprising there at all in the 5 volt regulator. We've got the, oh yeah, I've got some notes there about what is connected to what. And then, yeah, so that's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, I think, for those, the 4 bits coming from the rotary encoder. And then we've got the 4809 with a bit of decoupling. We've got an RS422 driver here. Okay, Stephen W says, wash down the coffee with a triple shot. Triple shot of what? I have a coffee. I am going to take a swig. I'm gonna mute myself while I do it. Okay. Now I'm back in squirrel mode. Just got to let that caffeine enter my bloodstream. All right, so I've got an ISO 3080 serial to RS422 driver chip, which was ridiculously expensive. They're like $8 or $9 each. But hey, I'm only building one of these, so who cares? Well, I'm actually going to build two, I think, because I want to build one to put in Steve's machine and then have another one as a spare. So I'll set up two identically because this is going into a CNC lathe, which is critical to Steve's livelihood. He makes stuff on this machine, and if it goes out of commission, then he needs to be able to bring it back up. And if part of its control system is based on a custom board that only I know how it works, that is not good. So I'm going to make a spare, assuming that the first one works. Okay, so we've got the UPDI header for flashing. Oh, excuse me. Now this RJ45 connector is to take the twisted pairs of the RS422 and take it across to an RS422 connector which matches on the other side on the Linux CNC board that this is going to plug into. So the whole point is that what I'm going to have to do is write firmware to run in the micro which reads the position encoder and then reports back over the serial connection to Linux CNC, telling it the position of the tool changer and whether it's engaged or not from the inductive sensor. So I have no idea if this is going to work, but this is what I have. What I've got is, say, bit 0 coming in from the encoder. This is running at 24 volts. So there's 24 volts supplied to the rotary encoder. And the encoder, I believe, will be pulling it high or low. And I've got a bias low into the transistor, which is controlling the data line going to the microcontroller. And then we've got an LED with a pull-up resistor, which is providing the upward bias on that data line. So if the transistor turns on, it'll pull the line low and the LED will turn on and we will see a low value on this data line. If the transistor turns off, then the line will float high. It'll be pulled high through the LED and yeah, we'll see a logic high on the micro and the LED will turn off. So I've kind of cheated here. I hope this is going to work. I really hope it's going to work. I threw this together without a whole lot of thought. Yeah, using the LED as a way of biasing the line high. Which, yeah, we'll see. We'll see. Hopefully it'll work. So we've got the 4 data bits across the top. There's bit 0, 1, 2, 3, and then we also have a parity and a strobe line coming from the encoder, which are used for knowing that we have the encoder in a position where it can be read. And then we have a signal here. It's just called signal. Why did I call it signal? That's very generic. This is from the Hall effect sensor, I think. Yes. It's from the Hall effect sensor. So what happens, my very crude understanding, not really knowing how the mechanical side of this works properly, is that there is an inductive sensor on the back of the tool changing disc, and when the BT40 tool is sucked back into position, it engages the inductive sensor so it knows that it is seated properly. So when the tool is out of position, the sensor is not activated. And this is how we know that it is seated and then it is safe for the tool changer to rotate. So we need an interlock on the inductive sensor that detects that the tool is engaged in the holder. So then, and you can see here, sensor, so I've got a 3-pin header which goes to the inductive sensor, and we've got the 8-pin header here that goes to the rotary encoder. And then we've just got a couple of random inputs and outputs. So we've got a couple of opto inputs, which could be used to read from whatever. We don't really know yet. I just included them because Steve thought it would be a good idea. And we probably need to control a solenoid or something on the output side. So I've got a couple of switched 24-volt outputs as well with semi-chunky N MOSFETs. I think they're 5.5 amp rated or something. What have we got here? 223. Oh, I have been so lazy that I didn't even put the part numbers in. That is very slack of me. Very silly. Anyway, these are little TO223 package MOSFETs, which do a decent amount of amperage. So they're good for firing solenoids and things. There's a hydraulic solenoid that I think we have to control as part of this whole process. So that should allow us to take care of it. So that translates to this, which translates to this. And as you can see, there is so much spare space on this board. So much spare space. Look, I could take a centimeter off the left side of this board. No problem. I could just cut it straight down there. And I could take space off the right. I could compress all of this in. And but this is going into a machine that is the size of a decent sized car. Bigger, probably. And the control box that all of this goes in, I could climb inside it. There is so much, this machine is so big. There is no space constraint whatsoever. All of the control system is mounted inside this enormous control box, which has got rows of DIN rail mounted.
My skull has a lot of spare space.
So has mine, Pete. So has mine. Yeah, it's got rows of DIN rail mounted actual like motor controllers and stuff. I wonder if I've got a photo of it. I do remember taking a photo at some point, and because I was talking to Steve about it, and I said, like, is there anything in here that is secret or that you would not want revealed? And he said no, he was happy for it all to be photographed. I'm just wondering if I can find it easily enough. So I'm just doing a very quick scan back through photos from not that long ago. Photos. It might... Is this it? No. That was totally unrelated. Yeah, where? I could use Apple's location search thingamajigamy, because I could get it to show me all the photos that I took at the location of his factory. That might be the sensible way to find it. Let's see. Okay, photos. Just going to open Apple Photos and zoom in on Melbourne. Zooming. Where is his factory? Not there. Oh, that's the Baronia location. Where is his factory? Not there. Finding photos at strange locations. Sorry. I'm just off doing my own thing while you're all... no, that's Build Highway. What is that? That is... Oh, maybe that's where his factory is. No, that's Stud Road. What's going on there? Yeah. Oh, my... yeah, my... my phone has been confused about its location sometimes when it's been taking pictures. No, not that one. I'm going to give up on this in a minute. Maybe I just need to find... Okay, so Baronia, then I go there, then I drive along there, and then I turn down his street. Where do I turn down his street? Oh, there. Okay. Oh, there's the location. Let's see if there are photos in here of the internals. Nope. Okay. Damn it. The location search has failed. It's found a whole lot of pictures from when I was... Oh, what's this? Time for a coffee? It is. Yeah, you can tell. You can tell that my brain is is being strange right now. What is in there? Any photos there? Nope, that is none of those. Okay. I thought that I had photos of the inside of Steve's machine, of this particular Mazak lathe, but who knows? I can't find them. Point is, the whole point of what I was just telling you about. So, John, thank you for the £5. Okay, I have to take another swig of this now cold coffee in honor of the contribution. And that was actually the end of the coffee. It is now gone. I am coffeeless until I spend your oops, your £5. Yeah, where is that it? No, I've got photos here that look like they would be photos of the inside of his machine when I look at the thumbnail, but then when I actually open them, it's not. It's other miscellaneous equipment. Henrik! Wake up, Henrik. Maybe that music just woke you up. Thank you for 17 months of membership. Okay, I'm going to give up on looking for pictures of the inside of the machine. And get the nut. And yeah, the point is, this board is a little board inside an enormous control system in a big metal cabinet, so I don't have any space constraints. So I actually deliberately made the PCB bigger than it needed to be. David C says, £5, that's like 1,000 Australian dollar bucks. It is.
Pete said, Steve and Steph proof of life, please.
Steve, Steph. There we go. Steve and Steph, proof of life. They are off chasing nuts. Bye-bye, Steve and Steph. Oh, that's so silly. Still cheap for a coffee in the UK at the moment. Steve. And, as Scott is about to say, here it comes. Can't forget, Is it going to work? A TTS got confused. It's got the same thing twice instead of the second one. I don't know what's going on there. Okay, so the point is, I actually made this PCB bigger than it needed to be, just so I could stick labels on it. It felt so wrong, and also you can see there's a typo. Or did I fix it?
Scott Miller said TTS balk.
TTS balk, yeah. So, so in 1A, in 1K, so I've got anode, cathode on that side, out. Oh yeah, there's the typo. Look at this, out 1 plus, out 2 minus. There's a copy paste error. Out 2 plus, out 2 minus. So the PCB is bigger than it needs to be. It's like lazy lane. It's like comfort lanes, nice and wide, plenty of room just to put labels on there. Now, what I want to do, Henrik is sending me a burger. Say, by the way, I don't convert to lowercase. Henrik! Thank you, Henrik. Well, now that the TTS is back, we are taking full advantage of it. Now, what am I doing? Oh yeah, so the point is this. It's real. This is it. This is the board. It arrived during the week. I assembled it. I have no firmware to go on this yet, so I don't actually have anything that can run on it. But what I want to do is hook up the rotary encoder. Now, Steve has made me a really cool test rig. Now, how am I going to show this to you? I think I'm going to do this using just the face cam, because it is kind of awkward. Check this out. It's all on a...
Henrik Ostrov said, Alexa, hi.
Sorry, Henrik. Alexa is not doing anything at the moment. Okay, so what might be familiar to you from previous adventures in encoder land is this. This is the rotary encoder, and we had this just sitting out loose on the bench last time. It goes to this connector, which is that big weird mil-spec connector that someone found the part number for. Someone tracked that down last time we were dealing with this. And that connector goes to the encoder and to this inductive sensor. And so what Steve has done is reproduce the structure of the... Flash Gordon ray gun, says John. Yeah, it is. It's like... he's reproduced the structure of the tool changer. This disc that you can see is approximately the size of the tool changing disc, and what you won't be able to see is there are little marks. He's marked it at the positions. There are 8, so they're at 45-degree offsets. There are marks for the positions of the tools. There is a drive coupling in the middle and a motor. So this motor is not actually from the machine. This is just for our testing purposes. It's a gear motor, and when this is given, it's a 12-volt motor, but when it's given about 4 to 5 volts, it turns at a speed that approximates the speed of the tool changer, and it drives the disc around. So what we can do is use this motor to drive the disc, and we can see the little marks on it to be able to check the accuracy of the indexing, and then we can read off the rotary encoder to see the position of it. Now the goal here is to control the motor. Now, in the real thing, this movement is done hydraulically.
Pete said, would it save you a lot of time if I just gave up and went mad now?
Yeah, do it. Pete, go mad now. So the, on the real thing, there is a solenoid that controls the hydraulics that drive the thing around, and it can be driven in either direction. So if you've got a tool in this slot and you want to change to this slot, then you unload the old tool and then you rotate the disc and then you load the new tool coming out of the holder. And the idea is you move in the direction that is the shortest path to your destination. Now, that is just an optimization. Now, it would be acceptable to only ever drive it in one direction, which means that if you were wanting to move from this slot to this slot, you may have to rotate.
Amanda Thompson said, "Aren't we all bad already?"
We are all bad already. Mad. Bad and mad. So to move from this slot to this slot, you might have to rotate all the way around, like 330, what is it? 335 degrees to get to the adjacent slot if you go the long way. So an optimization is being able to rotate in either direction so that you can take the shortest path. But that's
Pete
for
said, "That looks like one of them fancy
down the track.
microphone listening spy things."
Yeah, it's like something that a Russian spy would point at a window to listen in at the US embassy, or that sort of thing. Yeah, so the idea is that we connect this to this. If I slide myself a lot back across here, so here is the big sci-fi gadget. I'll just move that slightly off. This is the connector that goes to it. So what I want to do is join that to that. That is the challenge. Where did I put them? I got some connectors out earlier. I'm sure I got them out earlier. Oh, there they are. They're on the bench hiding. So we've got some screw terminals here. This goes into here. This goes into here. And then I need jumper wires that go from here into here. And if we power it up, the encoder should work. And then if we apply a voltage to the motor should spin, and then we should see the LEDs here turning on and off as the different bits of the encoder go through their different states. So, I'll get this off. Steve put the connector in a plastic bag to protect it from contamination, all the bad stuff that goes on in the factory. So the first test I think we could do is hook up.
Is this the psychedelic mechatronics show?
It is the psychedelic mechatronics show. I need better lighting here, don't I? I need like a more intense bench light because this looks so dim on camera. It's not bad just to my eyes sitting here looking at it. It's not a dark bench. I think part of it, actually, what happens if I turn the microscope off? Does that improve it? Yeah, it does kind of improve it. I think the camera's, like the illumination on the camera was adjusting for the fact that there was bright light coming from the microscope. So now that it's not having to compensate for that, it means that it's changing it's adjusting its, there we go, lightens up, its aperture setting. So first step is connect the pins from here which go to the inductive sensor and see if we can read that with this board. We don't even need the micro to be doing anything because I put LEDs on all of these lines. So if we change the state of anything on the encoder, we should just see the LEDs turn on and off. And that'll tell us whether we're getting the signal coming in from this. And so my super cunning plan is to cut a bunch of bits of wire and then heat shrink it on. So let's, I need something as a length reference so that I make these all the same. What'll I use? How about, I don't know. I just need some arbitrary thing. That'll do. this will be my length reference. I'm just going to make them the length of that one. Oops. Yeah, and I know I could cut the first one and then just cut all of the others to match, but yeah, well, this is the way it goes. Okay, so then even if we just get the inductive sensor working now on the stream, that will be a little bit of a start. I have no idea how all this is going to work, but I'll try to describe what I'm going to do. I need to be able to connect into this connector. Getting into the back on it is really hard and annoying.
Said, did you receive the hot dog I bought?
Oh, I did. Thank you for buying me a hot dog, Henrik. I don't know why black button on a black background then lights up in black. Yes, Paul. Yes, hot black Desatio. Performing from a spaceship in orbit around another planet. So, yes, Henrik, thank you for the 1.49 euros. Oh, that is very cool. Up there is a poop as well. Oh, thanks, Henrik. And the 0.99. So you're buying emoticons. Okay, back to here. Now, I don't know how well this is going to work, but yeah, and as, who was it? Someone said, yeah, Scott, all black wires, confusion isn't a thing. Of course it isn't. Confusion isn't a thing. I'm going to grab some heat shrink and try to heat shrink this cable onto, so I'll do it all with all black heat shrink just for Scott. No, maybe I won't. I'll grab a few different colors of heat shrink here. And so we've got, I don't have any brown heat shrink. Oh well. What colors do I need? I need blue, black, and I'll just use a green, just cause. So, my cunning plan, I need to connect onto black, let's use that one, is to just heat shrink the wire onto the pin. So, this might be the most, I've never done this before, this might be the most awkward thing ever. But in my head, it seemed like a great idea. Fantastic idea. Okay, so I'm going to put the wire down alongside the pin, push the heat shrink down onto it, pull the wire back up just enough. All right, now I'm going to try shrinking that heat shrink, and we will see whether the wire grips onto the pin. Come on, shrink, shrink, shrink. It may just pull straight off, like it may not have any adhesion at all. I'm going to try very lightly. Does it move? Oh, it actually seems to be adhering. That's cool. All right, time to do the next one. So, blue. Amanda! Thank you, Amanda. This has been a very musical live stream. Now that we've got the TTS back up and running. Okay, so third row, and I want to push that on and then pull the wire back up just enough that the strands are not sticking out the end. There we go. And I'll heat shrink that one. And the last one.
Ostrov said, could you use a 2mm banana head or SMT?
Could I use a 2mm banana head or SMT or something? be, but I don't have one. Yeah. I don't know what the diameter of these pins is. Let's see. Pin diameter is about a bit under 1.6 millimeters. So, okay, last pin. Brown is second row on the edge. It is right about there. Push the heat shrink down, pull the cable back a little, and heat shrink. Okay. So now I should have the connections for the Hall sensor, and I should be able to connect them into this. Use my sonic screwdriver and now what's the order? Okay, so brown, black, blue. Brown is that one, so we'll go brown, black. Where's black? That one there is black, and come on. Okay, black and blue is that one. And because I I used all this extra space on the board to put nice colored, nice labels on there, it makes it very easy. Okay. So now, this LED...
Pete said, dentist noises, AARGH.
Dentist noises, yeah. Now, how am I going to do this? All right, I'm going to move this so that this is in your field of view about there. Then I'll move this big mechanism in here. And what you can just see up in the top left, this part here, this is the inductive sensor. And this is a bit of metal, whoops, that moves up and down to activate or deactivate the sensor. So I need to get 24 volts onto this. I need one of my handy dandy pre-made cables, all color-coded. It's got green heat shrink on the end so that I can just grab it out. I know that it's that one.
Henrik Ostrov said, does your board give out 24 volts for the sensor, or what voltage did it run?
It passes through the voltage from the power supply. So the lathe control system runs on 24 volts. And so what I'm going to do is set my power supply VSET 24 volts. I'm going to current limit it at 200 milliamps. That should be plenty. And okay, let's see if the smoke comes out. Now, what should happen is we should get a power LED on this somewhere. Where? Up there. Okay, there's a power LED up here. And that should turn on. And if that turns on, it means that we don't have a short circuit. We'll have 5 volts, which is going to the micro, but we don't care about that. The 24 volts from here is going to be passed straight through to the inductive sensor. So here we go. I'm going to turn it on. No smoke came out. And look, there's a green LED. Now, this is it. This is the moment. If I lift this, does the green LED turn off? It works. Look at that. We are detecting the... I'll move this so that I'm not blocking the view. We are detecting the inductive sensor being activated. Ooh, this gives me hope that we're on the right track here. So now what I need to do is hook up the lines for the rotary encoder, and then in a similar way we should get, I'm just going to turn that off, we should get the state of all of the bits and the strobe and the clock. I've successfully invented Morse code. Yes, Stephen. Yeah. So now I just need to do this a bunch more times. 8 more times. Oh, 8 times? 8 times. I can manage that. Not the most fun thing to be heat shrinking these wires on like this, but it does seem to work. So let's give it a shot. All right, I will clear myself a little bit of space. I'm going to move that. Oh, actually, what I'm going to do, just because this is going to be a spectacle slightly, is I'm going to put power on the motor to make the disc turn, because I just want to see that happen first before I go to the trouble.
But can we?
Can you? No. You definitely cannot manage listening to more of me talking nonsense. Okay, what I'm going to do is I have my alligator clip power lead here. I'm going to move this into a position where you can see the disc, which is not that easy. Then I'm going to set the power supply to 5 volts.
All cables are heat shrunken, then fill it with heat melt glue AMD. You got a connector.
Yeah, that's true. Got a connector, and well, sort of, except that it would probably end up adhered to the. See, I set it to 2 amps. Adhered to the thingamajigamy. All right, how am I going to connect onto this without a short? I need the cable that goes onto the back. All right, let's just see what happens. I'm going to turn on this power supply.
Fill it with epoxy.
Oh, look at that. You can see the motor's turning. Okay, so this is the motor turning, being supplied with 5 volts. And this is approximating the speed at which the tool changer runs when it's being driven by the hydraulic system. Okay, so that is what we need to detect. We need to detect the output of the position encoder as it is moving at that speed. This feels like a high school science experiment. So now I need a bunch more of those wires. Let's do some more wires. I need 8. What I'm tempted to do though is do just power, ground and 1 bit initially to see if it works before going to the trouble 3 of doing them all. 4. Or we can just go for gold and connect them all. I've lost track. How many have I done? 3, 4, 5, 6. Okay, 2 more. 7 and 8. So I want a long one end, short one on the other end. Yeah, and as Scott said, all black, so absolutely no opportunity for confusion. If we make everything the same, then of course it's going to all be correct, because you can only ever get the black one in the correct place. I'm sure I have mentioned this many times before on stream. I hate wiring looms. Like, I hate doing point-to-point wiring. I hate making up, like fitting up connectors. Oh, same creds, it's up. Oh, has TTS been down? Let's see. I'm just going to reload. And has it stopped? Okay, I am logged back in again. Ah, here, let's play this one.
Ostrov says, next idea, buy a cable cutter, stripper machine to make custom wires for you.
Oh, I am way ahead of you on that one. That is a whole what you are talking about is a squirrel alert. What we need is we need a big animation and sound
Amanda
effect.
Thompson said, all T model Fords came in black only.
Yeah, we need a squirrel alert animation and sound because I have actually done part of the design and bought some of the parts to make a wire cutting and dispenser tool where you just you put a roll of wire in and you feed it in to a little tube, and it's got like a pinch roller to drive it.
Pete said, squirrel logo electrical and gaffer tapes.
Yeah, and then like a stepper motor to drive the pinch rollers. So you program how much you want, and it dispenses it and chops it. And alternatively, you could have it so that it would partly close to put a cut in the wire. And you could even have it so that you could do a trim and then withdraw the wire to do the to expose that, and it would drop the insulation and then forward feed it again. And then, yeah, anyway, that is Henrik, I have been way down that rabbit hole. I just haven't mentioned it on a stream because there are already too many. Yeah, I think what we need to do is, if I switch back to this view, I need to rig up some way of throwing up this little dude as a squirrel alert. Okay, time to do some more chopping and heat shrinking. I'm just gonna chop a few. How many do I need? 3, 4, 5, 6, 7, 8. That'll do. They're slightly different lengths, but oh well, close enough. Yeah, this is gonna. They do. You can pull them off. They're not totally secure, but they're not too bad. So as long as I'm careful, I think it should be reasonably safe. All right, so this one, brown is, no, I've already got that one. Okay, so purple, I need to do top there. Now, am I going to risk putting several in and then heat shrinking them all at once? I think I shall. Living dangerously. We are now in the year of living dangerously. Now, oh, come on. This would be so much easier if I had a matching cable with flying leads off a connector that goes into this. However, the cable that goes into this is threaded through the inside of Steve's lathe, and it's not worth the effort. Hang on, which one? Second one down. Okay, so I need to do 3 in a row going across from there. Second row down, 3 in a row. Okay, got it. So into there, and then another one in beside it. So yeah, Steve said to me that if I really wanted it, he could extract the cable with the connector that goes into this, but it does thread down through the machine. So it would end up being a bit of a pain. A bit of a pain to get it out, and then a bit of a pain to put it back in again, because it goes from the location of the tool changer mechanism and threads through the machine to get to where the control box is. And
Cable Tie said, someone just joining the stream would be justified in asking what on earth are you doing? John.
Cable tie! What on earth am I doing? All right, what I am doing is hooking up a rotary encoder, which is attached to this big high school science project looking device. which is out of a CNC lathe, and I'm hooking it up to this control board that I designed, which reads from the encoder and then has an RS485 interface to report back to Linux CNC so that it can control the tool changer in the lathe. But I am now hooking up the outputs from the encoder so that we can connect them into this. Okay, now, next. Where are the other connections we need? Yeah, it's getting to the point where it's becoming precarious. All right, so we need 2 on the 3rd row down. So I need, 3rd row down, I need that one and the one beside it. So I'll plug that one in first. Yeah, and because the other part of this cable is still inside the lathe, which is a very large piece of equipment and complicated cable paths and things, I'm making do with trying to bodge connections onto the pins so that I can test this little board before we fit it into the machine. And also I've got to do the software development to do the firmware that goes onto this interface board to read from the encoder and report back to Linux CNC. Okay. Oh, we're getting there. So which connections do I need next? 3rd row from the bottom. Oh no, that's the inductive sensor. Okay, 3rd row from the bottom, 2nd in.
Pete said 3 minutes.
3 minutes to what? Oh, to the end of the stream? Nah. Now that I'm this far along, I want to get to the point of actually seeing if this works, because we're so close to hooking this up. Second, where was it? 2nd one in, so it's next to that blue one. It's getting to the point where it's getting kind of tight in here, getting all of these cables into place. Okay, push that in, pull it back to bring the strands up against the side of the pin. Right, there is good.
Scott Miller said 3 minutes to bodge hour.
To bodge hour, yeah. I can go slightly over time today, but not dramatically, because it is this afternoon there is a family event for my stepmother's 80th birthday, which I'm going to be going to, which is really cool. I'm looking forward to that. It's an afternoon event. It's not a lunch event, so I don't have to like rush off straight at 12 o'clock, but I also can't stay around for hours and hours. So, now, okay, now where next? I've got those 2 on, got that one. Okay, so then we need row 1, 2, 3, row 4, 2nd one in is row 4, 1, 2, 3, and then, 4, 1, 2, 3, 4, 2nd one in is that one there. And
Henrik Ostrov said, "That EHY you're not eating RN."
that's why I'm not eating right now. I'll probably still need to eat something before going to the event, because it's not a lunch, it's just like an afternoon soiree. Oh yeah, so I encourage you people, make liberal use of the TTS right now, because I'm not looking at the screen, so I'm not seeing chat. Okay, one more. Where is the last cable to connect? Which one of these does not yet have a
Tabray's Malik
wire in
said,
it?
"Say happy birthday to Mum." Pete said, "Food times." Did ya get M on the right pins?
I don't know.
Said, "Dislike and unsubscribe everyone."
Yeah, dislike and unsubscribe. Make Pete happy. Where does that bit of heat shrink go? Oh, it's there. Okay, so that is third row down. 1, 2, 3, 4 in. Do I have all 4? 1, 2, 3. No, am I short of a piece of wire? What is going on here?
Henrik Ostrov said, TTTSS, TTS, TTSSS, TTSS, TS, TTS.
What? Yeah, okay. You made liberal use of TTS. That is taking it literally. Have I put a connector? I have the wrong number of wires, and I'm wondering if I have screwed up somehow. Okay, so third row, fourth row, 1, 2, 3. Why do I have one? Oh no, that's right. I have one on there, one on there. Okay, I'm just going to start connecting them up in a minute and see what is not connected. Hopefully I got the colors right the first time. All right, so that I've got 3 on there. I've got on the third row down, I need 4, but I don't have enough wires left. Did I not cut enough wires? What is going on? Third row down, 1, 2, 3, 4. Maybe there's one that's not connected. There's a green. All right, I'm gonna. Yeah, this is where the color confusion starts coming in.
This is your life. Cable Tie said, TTS seems to be only saying every second or third post.
Oh. Is it? Okay. Okay. Now I'm going to heat shrink that one. I'm going to start hooking these wires up to the connector, because then by a process of elimination I will see what I have got and what I have not got, and whether I have screwed this up. Okay. I can't remember. I have a feeling that it might be colors that are not used, or there is a signal that is doubled up or something like that, which is probably why I have one fewer wires than there are things coming in on the connector. So what have we got? Violet, white and grey. All right. White and grey is the one that is row 1, 2, 3, 4, and it is second in. So white and grey is this one, which is going into pin 2. I probably should have made these wires a little bit longer, given myself some more leeway, so I'm less likely to accidentally pull connections out of here. Okay, so violet. Where is violet? That is that one.
Building a smoke production facility.
I certainly hope so. Violet is that one. That just depends how much I turn up the current limit on the power supply, doesn't it? What have I think I can go up to 12 amps on this particular power supply. All right, violet now. We need black, brown, red. Black is...
Ostrov said, Va tutto bene isai ancora, cosa stai facendo?
What? I don't know. One of those. Is that one of those health rings? Says Espro. Yeah, it's a Ringcon ring, which is a smart ring. It's got sensors in it. Don't know if it'll flash and you can see it. It's got, you can see 2 little studs in there. Oh, you can see it flickering now, those LEDs. That's it trying to detect my pulse and blood oxygen. So yeah, it Bluetooths back to my phone and logs data. Oh no, one of the things has fallen off. I don't know where that one came from. Oh, okay, that is for the inductive sensor. All right, I'm not so fussed about that because we've already proved that works, but I will need to try to reconnect it. Okay, so these 3 wires here, there is this one. Where does that go? Hang on. Where does that go? Why is that into there? Oh, okay, it's for that. Okay, I don't need that one. So I need brown and it's the other black. So I need brown and red, these 2 here and here. So this one.
Scott Miller said, "Should a epoxy filter housing?"
Yeah, but this housing needs to be used again. Okay, so brown and red. I'm going to skip one, goes into the brown slot. Yeah, it's got to go back into the machine. That's the reason the connector is being retained. Otherwise, I would cut this off and replace the connector with one that I have access to.
Cable Tie said, "Do you actually have a mating connector somewhere?"
Yeah, the mating connector is still physically inside the machine, which is why I don't have it. Taking it out of the machine would mean unthreading a whole large part of the wiring loom of the lathe. So it's several meters of cable running through the machine. Now the one next to that, which is that one there. Ah, yeah, these are starting to pull out a bit. This connection method is not as reliable as as I would like. Okay, I'm going to try to that way. Yeah, I'm going to try to reinsert this. This might end up being a bit of a losing strategy. Now, where was it? It was there, plugged into that one. And that was going to the red connection. Red. And in a total fluke, it actually has red cable tie, not red cable tie, red heat shrink on it. If I had more colors of heat shrink, I could have color coded all of the connections. All right, I think what my goal should be is to get power to this, and so power ground, and just...
Cable Tie said, "Did someone say cable T?"
I did say it, but I don't know which one of these is actually... I'd have to look up the schematic. Come on, I can do this. Only 4 more. I only need 4 more connections. All right, so I need green, yellow, and orange, and I need the black connection. I can see there is orange is 3rd row down, and it's on the end, so it's this one. This one is orange. Okay. Orange goes to the 3rd one up, which is there. Yeah, so what's going to end up happening is that when this is installed in the machine, there is a cable in the machine which has the matching connector that goes into this.
"You already have the black connection."
Maybe. So there's a matching connector that goes into this, then a cable that goes several meters through the machine, and it comes out with flying leads in the control box because it went to the old controller, which has now been totally removed. Steve gutted the entire control system of the machine and has built a new one. And so then that flying lead, what we'll do is we'll clean it up and we will screw it in all the appropriate colors into one of these pluggable headers to match what's on the PCB here, and we should be able to just plug it in. But for now, I have to do this cobble together thing to get this sorted out. Okay, so next we need yellow and green. So the next one in from that is third row down, second one in, which is this one. So this is yellow. And keep up. And then green is the next one in from that, I think. So it's third row down, third in, which is this one with the red heat shrink on it. That's the green connector that goes to the end point. Okay, and now what's this last one? So the last one I don't have. The third one is black. It's a different black. So this, is this it? Second one in, I don't even know what, so I've got one here that I fitted, and I don't know what it's for. Okay, it is going to third row up, second pin in, third row up, second pin in, which is blue. Why do I not have, I do not have a blue anywhere on here. Maybe I'm not using blue. Oh, looks like blue is shield. Okay, so that should be doubled in. It doesn't, for now, I'm not going to care about it. But what I should do is double that one into the ground connection. So what I need is black, which is fourth in on the third row down. 1, 2, 3, 4, which is this one. I am really getting myself confused. No, I don't have the fourth one in. I don't have an actual thing into it. Okay, I'm going to repurpose, or will I? No, I'm just going to make another bit of, I'm going to cut another bit of wire. Is the more sensible way of doing this. I should be trying not to take too many shortcuts. I'll leave this, this explains that my whole confusion a moment ago about why do I have one wire too few. It's because one of the wires that I connected to is the shield, and I wasn't allowing for the shield as a separate connection. So we should be able to just add this 9th connection, and it goes to black. All right, if I look at it from the opposite point of view, it is third row down, third in. Does that make sense? Third row down, third in. Yes, it does. Okay, so I want it to go right there. It's getting awkward, it's getting very tight in this connector. So now I need to pull that wire back a little bit. Okay, and then heat shrink it so that it will stay there. And that will be black, which is the third one down on the connector, which is there. Better make sure I'm getting the right one. Okay, that one is black, which goes in here. And you might think that, yeah, black is ground. No, not necessarily. The color coding on these can, and you might think, yeah, red is positive, black is ground, but no. The colors are definitely not aligning with what you might expect. Okay, here we go. Back to, oh no, what I'm going to do, just for completeness, is I'm going to reconnect this one that fell out. So this is the one off the inductive sensor, because I want to get it completely hooked up. Now, which one fell off? We've got second row, it's this one, okay. So that should give us brown. Yeah, okay. apart from this one, which is the shield, we should now be connected. Okay, here we go. This is going to be smoke time again. I'm going to hit power, which one? Power to, not 5 volts, I want that one. Okay, here we go. So we've got a bunch of LEDs on, and I made the mistake of looking at it. So now, here we go. And if I, so if I move the metal next to the inductive sensor, you can see that bottom LED is turning on and off. And now what I'm going to do is hook up power to the DC motor, which is running the disc. I'll see if I can get this into the field of view. Okay, and now, moment of truth. If I turn on the motor, we should see the LEDs flicker. So let's see. Oh, look at that! We have rotary encoder data. Oh, this is so cool. So the disc is turning, and the rotary encoder is hooked up through these transistors, and you can see it's so, I should have put higher value current limiting resistors on the LEDs. This is so cool. And then we are getting the state changes on the 4 bits of data and on the strobe. And look at this one. See where my finger is here? See, this one is turning on and off at a slow speed. Off, on, off, on, off, on, off.
Henrik Ostrov
And
said,
then
it looks like binary.
it's similar to binary. It's grey code. It's not quite binary. So the idea with grey code is that you can detect transitions bidirectionally, and yeah, anyway, that is a whole complicated thing, which I talked about a long time ago. Well, this has got to be one of the most successful live stream bring ups that I've done so far. So this is a brand new board, version 1, and so far this seems to be working. Now, of course, we're not detecting this with the I'm gonna tweak the voltage a little bit. So V set there. I'm just going to turn the knob.
Henrik Ostrov said, can you reverse the motor?
Yes, I can. So I'm turning the voltage down. It's now running at 3.7 volts because I want to slow the motor right down and see the speed so that I can see the transitions on those LEDs. All right, I'm going to turn it way, way down. It's now running on 2.4 volts. And you can see the LEDs are flickering more slowly. Very cool. Yeah, I could reverse it but you wouldn't really see any particular difference. The LEDs would just flicker in a slightly different pattern. Now, oh yes, sorry, I did not properly explain myself earlier because when I said it's kind of like binary but not, it's grey code. Yeah, some call it fun in the chat. Just completed the explanation that I trailed off on. Binary can have multiple level changes at once, but with grey code, only one level changes at a time. Yep. So if you have a binary counter and you ripple over, oh, Alan said do it by hand. I can't, but I'll explain why in a second. If you have binary and you increment a bit, that might flow over and cause multiple other bits to do a state change. But with grey code, it rearranges it so that you only ever get one bit change at a time. And there are reasons for that. Anyway, I talked about grey code on a stream ages ago when we were first looking at this encoder. Maybe I'll get back into it some other time, but for now, no. So what you see here is only one bit transitions at a time. Now there are a couple of So there are four, this is a 4-bit grey code encoder, but we have 6 LEDs here. And that's because we also have a strobe and, oh, Crispin said about 4 months back. Was it that? Okay. Yeah, so there is a strobe and something else. All right, I'm going to turn this motor way, way down. I'm going to get it running as slowly as I can. It's a 12-volt motor and it's now running on 1.9 volts. 1.8, 1.7, 1.6, 1.5, 1.4. It is just turning over. 1.3. So now the LEDs are transitioning much more slowly. That is so cool. All right, so the next thing I've got to do is actually write the code to read those inputs. Just turn it down, 1.2 volts. It's sort of stuttering a little bit now. The motor is, you can't see it. The motor is just off the corner of the thing. So this is the drive coupling, and then the motor is hanging off in the top left corner of the screen. I'll see if I can push it a little bit more without making these wires fall out. So the motor is running into this gearbox and it is just barely turning over. 1.1 volts. It's probably going to stall any time now. 1 volt. Okay, it's running at 1 volt and just turning over. But that actually works really nicely in terms of being able to see the transitions on the LEDs. So we're now getting data. Okay, so I need to write firmware to go on this microcontroller to read this grey code and report the position, and also control an output to a solenoid to make the motor stop. Because the whole point of this is that we want to be able to send a request. Okay, so here's the big picture. Linux CNC, which is running this lathe, is going to send a request over RS422, which is going to come in on a connector on the side here, to this board, and it's going to say, give me tool 3. And then this board needs to send an output to the solenoid to control the hydraulics, to turn the disc, and then when the disc gets to the position that it wants, it needs to, based on the value coming back from the encoder, it then needs to turn the solenoid off, which then stops the hydraulics and stops the disc from moving. So then it reports back. Oh, and then it would engage, like once the retraction thing has pulled on the bolt of the BT40 mount on the back, and whoop, the hall sensor goes chunk. So normally when the tool is out of position, the sensor, I said hall sensor, I think it's an inductive sensor, is not tripped. And you can see that the LED down here is off. And then when the tool is pulled into position and locked using the draw bolt, then it will go boink, and then it knows that the tool is fully engaged, and etc. And then, yeah, so strobe appears to be bit 1, says John. Yeah. Scott says it's grey code plus a strobe signal. Yeah. Yeah, I'm sure I can see bits 0 and 2 coming on together. Oh, says John. Yeah, so there are, I actually don't remember the order of any of this. We can look it up in the design. We can smooshy on over to here and have a look on here. Because, where are we? Okay, so parity is the top one. Then strobe is here. What you might be seeing is the parity bit coming on and off as other things transition as well. So we've got bit 0, 1, 2, and 3 are the bottom 4 coming off that connector. And at the top we have parity and strobe. So the parity bit is a check bit, and to make sure there are no errors. And the strobe is a signal that says when it is safe to take a reading, like when it is within one, it's not in a transition state. So you know when you can take a reading from it and trust that it is not in that moment transiting between one state and another. Yeah. Anyway, that software is a problem for future me. Not far in the future me, in the very near future me. But yeah, I need to work that out. So what I'm going to do, step one is I'm going to get some firmware on the micro that will read from these inputs and decode the grey code and give just like a numeric output, so I can know the position of the encoder and report it on through serial onto the UPDI connection here, so that my UPDI/serial debugger can tell me what is happening on it. Then I need to add the RS422 serial communications coming through here, speaking whatever protocol Linux CNC wants it to be speaking. And then I need to add the logic around the interlocks of things like reading the inductive sensor to know when the tool is locked in place, and doing things like reading a requested tool position and moving to it in whichever direction is the most efficient, so the shortest path to move to that, and then stop the motor or stop the hydraulics at that location to do the tool change. Wagon Load says you need to write test code to check if you have any wires reversed. Henrik says, can you ask from Copilot a simple test code? Would it make it real easy? I don't know, maybe, but I think I'm just going to write it myself. Technebulous, welcome, welcome. Okay, so I am now half an hour overtime, but we have success. We have success. We have the turret rotating, and we have the data coming in from the encoder, and we have the data coming in from the inductive sensor. Yeah, I don't know if the micro is reading it, but the LEDs are turning on and off, so it's good enough. That's fine. I trust it. I believe it. Oh, okay. I'm really chuffed about this. This is cool. This is cool. We have got... Oh, I meant right now, so we can see more success. Nah, I don't have to super rush off, but I do have to not also hang around unnecessarily, because I need to get over to the other side of town. It's quite a drive to get over to my stepmother's birthday party. So I'm going to leave it at this point. And yeah, that is cool. We have it working. It is working. So thank you all for coming along. I appreciate everybody's help and suggestions and input on this, and a lot of which was a long time ago when we did the stream with this encoder previously, because that is what led to me figuring out how this works and being able to design this board. So yeah, great success, great success. If you dangle a squirrel, it will chase it. Yes, that is the problem. I will chase
Outside
that
the
nut.
box said, Uru.
Uru, Crispian, and Uru, everyone else. Thanks for coming along. Have an awesome week. And as usual, during the week, pay attention to the good things. Pay attention to find one thing that you can bring along next week for a nerd brag. Something cool. And I will see you all really soon. Thanks. See ya.